Today, we will talk about one of the most exciting and latest projects in China's space program, the Chang'e 6 mission, which aims to land on the far side of the moon. This mission opens new doors in space exploration and demonstrates how far China's space program has advanced. Let's embark on this exciting journey. The Chang'e program, named after the moon goddess Chang'e in Chinese mythology, is China's lunar exploration program. It was launched in the early 2000s with the goal of exploring the moon and laying the groundwork for manned lunar missions. Through this program, China aims to secure a solid position in space exploration. Initially, the Chang'e 1 and 2 missions mapped the lunar surface, gathering crucial data for future missions. The challenges faced during the initial stages of the Chang'e program and how these challenges were overcome are indicators of China's advancements in space technology. In 2007, Chang'e 1 was launched as China's first lunar orbiter, tasked with mapping the moon's surface and conducting various scientific measurements. Chang'e 1 created a three-dimensional map of the moon's surface, providing significant data on its mineral composition and geological structure. Launched in 2010, Chang'e 2 mapped the lunar surface in higher resolution and identified potential landing sites. These missions played a critical role in mapping the lunar surface in detail and identifying safe landing areas for future missions. Additionally, Chang'e 2 passed very close to the moon's surface, taking high-resolution photographs, which played a key role in determining potential landing sites on the lunar surface. In 2013, Chang'e 3 successfully landed on the moon's visible side, deploying a rover named U2, Jade Rabbit, to explore the surface. U2 conducted various scientific experiments, gathering important data on the moon's geological structure and surface composition. In 2019, Chang'e 4 made a historic landing on the far side of the moon, becoming the first mission to explore this region. Chang'e 4's success in landing on the far side of the moon provided new insights into the geological structure and evolution of this unexplored area. Launched in 2020, Chang'e 5 collected samples from the moon's visible side and successfully returned them to Earth. This mission was significant as it marked China's first sample return mission. The samples collected by Chang'e 5 provided valuable information on the moon's geological structure, laying the foundation for future lunar missions. The primary goal of the Chang'e 6 mission is to collect samples from the far side of the moon and return them to Earth. This mission aims to provide critical data to better understand the moon's geological structure and history. The collected samples will offer previously unknown information about the moon's surface composition, minerals, and geological processes. The geological differences on the far side of the moon are a significant curiosity for scientists on Earth, and the samples collected by Chang'e 6 will help address this curiosity. The collected samples will provide important information on the moon's formation, evolution, and current structure. Particularly, these samples will help compare the far side of the moon with other regions. The far side of the moon, being isolated from radio signals from Earth, offers a unique opportunity for astronomical observations. Chang'e 6 will be part of the first detailed scientific research conducted in this region. These studies will help us understand the distribution of minerals on the moon's surface, the processes of their formation, and the moon's geological history. The Chang'e 6 mission will serve as a crucial reference for future lunar missions and even the exploration of other planets like Mars. The collected data will assist in identifying potential landing sites for future missions and in developing technologies to be used in these missions. Additionally, investigating potential resources on the far side of the moon is critical for plans to establish a permanent base on the moon. Many new technologies were developed for the Chang'e 6 mission. Advanced landing technologies, sample collection tools, and Earth return systems will be utilized in this mission. Sample collection tools will gather samples from various locations on the moon's surface, storing them in special capsules. Moreover, the landing module is designed to withstand the harsh conditions on the moon's surface. These technologies were developed to endure the extreme surface conditions and temperature fluctuations on the far side of the moon. China has also emphasized international collaborations for the Chang'e 6 mission. Technical support and scientific contributions were provided through partnerships with the European Space Agency, ESA, and other countries. ESA provided communication and navigation support, while other countries contributed to scientific research and technology development. These collaborations were critical for the success of the Chang'e 6 mission. Furthermore, these partnerships strengthened the joint efforts of the international space community in lunar exploration. The Chang'e 6 mission involved a detailed planning process. The mission includes phases such as launch, journey to the moon, landing, sample collection, lunar ascent, and return to Earth. Each phase was meticulously planned and tested. The technologies to be used during the mission were tested through various simulations and tests, identifying and resolving potential issues in advance. Chang'e 6 was launched from the Xichang Satellite Launch Center, aboard a Long March 5 rocket. The launch was successfully completed in all stages, and the probe began its journey to the moon. This launch was one of the most complex and technologically advanced launches in China's space program. The Long March 5 rocket successfully carried Chang'e 6 to the moon, completing the first phase of the mission. The launch was meticulously planned, and each phase was closely monitored. Chang'e 6 successfully landed on the far side of the moon. After landing, the sample collection tools were activated, and various samples were collected from the lunar surface. These samples were placed in special capsules to be returned to Earth. The collected samples came from different regions of the lunar surface, providing data to help understand the moon's geological structure and history better. The landing module operated in various regions of the moon's surface, collecting different types of samples that provided crucial information on the moon's geological evolution. The collected samples were sent back to lunar orbit and then began their journey back to Earth. The return capsule successfully landed at the designated site, and the samples were safely retrieved. The return process to Earth was highly complex and carefully planned. The return capsule re-entered Earth's atmosphere at high speed, protected by special heat shields. The capsule successfully landed in a specific area in China, ensuring the safe collection of the samples. The Chang'e 6 mission provided significant information on the geological structure and history of the far side of the moon, creating a substantial impact in the scientific community. The collected samples allowed detailed analysis of the moon's minerals, rocks, and other geological features. These data revealed previously unknown information about the moon's evolution and geological processes. For example, critical information was obtained about the distribution of different mineral components on the lunar surface and the processes of their formation. The far side of the moon, isolated from radio signals from Earth, offers a unique opportunity for astronomical observations. This region is less explored compared to other parts of the moon, making the samples collected by Chang'e 6 particularly important. Detailed data on the surface structures, craters, and other geological formations on the far side of the moon were collected, helping us understand the overall geological history of the moon. The far side of the moon is ideal for radio astronomy because it is free from radio signals from Earth. Therefore, radio astronomical observations made during the Chang'e 6 mission provided valuable information on the early periods of the universe. Additionally, the low radio noise in this region offers a unique opportunity for deep space observations, which is crucial for future scientific research. China continues the Chang'e program with plans for more advanced missions. Chang'e 7 and 8 aim to establish a permanent base on the moon, taking significant steps towards this goal. These missions will pave the way for lunar exploration and manned lunar missions. Chang'e 7 will search for water ice in the lunar polar regions and explore potential resources on the lunar surface. Chang'e 8 plans to establish a permanent research station on the moon, serving as a base for long-term scientific research and future human missions. China plans to emphasize international collaborations more in future lunar missions. These collaborations are critical for establishing a permanent base on the moon and paving the way for manned lunar missions. China aims to achieve significant advancements in lunar exploration and space research by working with other countries. These partnerships will strengthen the collective efforts of the international space community and expand the scope of scientific research on the Moon. China plans to conduct manned lunar missions under the Chang'e program in the future. These missions aim to conduct long-term research on the lunar surface and establish a permanent human presence on the Moon. Manned lunar missions are crucial for exploring potential resources on the Moon, better understanding its geological structure, and providing a stepping stone for future Mars missions. The Chang'e 6 mission has opened new doors in space exploration by successfully landing on the far side of the Moon and collecting samples. This mission has provided significant information on the Moon's geological structure and history, creating a substantial impact in the scientific community. China continues the Chang'e program with plans for more advanced missions and aims to establish a permanent base on the Moon in the future. These missions will pave the way for manned lunar missions and significant advancements in lunar exploration. We will continue to share exciting developments like these with you on our Spacetime channel. See you in our next video.